Welcome to another Maplecast. In this episode, we're going to be taking a look at getting started in Maple for this course. Several things I want to run through, the main things being differentiation, integration, and a small introduction to plotting, including some basic overall commands that you'll find useful. One of the things I would recommend is getting used to the layout of Maple when you first get into it, locating where the buttons are to make things bigger, where the formatting tools are, where all the drop-down menus are. And we'll start first by just creating a simple title here. So I'm going to center in the beginning of the page, switch it over to text input, and just type in getting started with Maple. I can increase the font size to be something more title-based, or if I want, create a format for the text. But I'm just going to leave it like that for now. And then I'm going to insert the sections. So the first section that we're going to look at is going to be differentiation. And so by hitting insert section, I can include the section, title it differentiation, and then all my work will be contained within. So the first command that I need to talk about is how to take a derivative. Given that this is a differential equations course, that seems appropriate. So the diff command is for derivatives. So you can do diff 3x squared comma x, and that will take the first derivative with respect to x of the function 3x squared. Now, if I wanted, notice that the output appears in the middle of the screen and it's labeled. So 1.1 refers to the first output in section 1. If I wanted to, I could also do the same command, but if instead of hitting enter, I hit command equal or control equal, depending on if you're a Mac or a PC, it will display the output right next to it. Sometimes that's useful, sometimes it's not. It just depends on how you're using it. So that's called an inline evaluation. Okay, something else that we can try is taking two derivatives. So if I wanted to take two derivatives of this function, I would just do what's called nesting. I would nest the commands inside one another. And so two derivatives of 3x squared with respect to x would be 6. You can also access through the calculus drop-down menu to the side several different operator commands. For instance, I could do derivative here, and there's different parts you have to fill in, and you can go from one part to the next by hitting tab. So I'm going to take the derivative with respect to x of, let's just say, the square root of x. And yes, you do have to type in sqrt for square root, or you can go up to expression and use the square root expression here. But I typically don't do that. It's just easier to write command line stuff than it is to drag and drop things out of the menu once you get used to it. So that will differentiate the square root function. And then I could also do that with the second derivative you see here as well, or specify the number of derivatives. I think an easy way to do things in Maple is to define functions for most of the operations you're doing. So suppose I wanted to define the function e to the x squared. The way that you handle e is by typing in exp, or use the e under common symbols here. And so if I wanted to do exp x squared, then saving that to a function, I just hit enter, and notice that that creates another line of output, and it associates x with the function mapping ex squared. Well, I could then differentiate what I've called it, which is differentiate f of x, and notice it would do the derivative there. Now, suppose I wanted to evaluate this expression. I could evaluate this expression by using the command eval, and what I want to tell it is I want to eval the previous line. Well, in Maple, the previous line can be called by the percent sign. So eval percent, and I want to do the evaluation at x equal to, let's say pi. So the command for pi is capital P, lowercase I, and you have to capitalize the P. So that's going to evaluate the previous expression at pi. Or what I could have done is use the labeling system that you see to the right by selecting Control L or Command L, and typing in 1.5, since 1.5 is the function output for f of x that I want to evaluate. And so I'm going to evaluate output 1.5 at x equal to pi, and I could also use the pi from over here in the side menu. Easy enough. All right, suppose I wanted to evaluate and differentiate all in one step, something a little bit more complex. I could nest those commands together as well, doing something like this that we wouldn't want to necessarily do by hand. So this would be the proper nesting, which would allow me to evaluate the derivative of natural log 3x squared divided by 2x, differentiate that with respect to x, and then evaluate the output at x equal to 1. So that gives me a pretty nice answer there. But suppose I wanted to know that in a decimal format. Well, if you right-click on outputs in Maple, they will often give you different options. So in this particular case, the option that I'm looking for is approximate. So I want to approximate this output to 5 decimal places. And there it is. And notice I could have approximated it to 10, 15, 20. It just depends on the tolerance settings that you have in Maple as to how many decimal places of accuracy that you can get. All right, we are also working with differential equations this semester. So instead of saving functions as f of x, I could save entire differential equations to some name. So suppose I wanted to name a differential equation ODE, and I want to enter the equation y prime plus 2t squared y of t equal 3 square root t. So that is a first order ordinary differential equation. And I don't really need to see the output. So if I wanted to suppress the output, I could put a colon at the end of that line. And notice it wouldn't show me any blue output there. It's still there. If I was to take away the colon, then it would show me the differential equation. But I want to suppress the output for now. There's no reason to show it. And then I could use this desolve command that we've talked about in class. So I want to desolve the ODE with respect to y. So I want to solve for y. Then we end up with this expression. And I could take this expression and I could do all different things with it. If there's some algebraic manipulation to be done, I could do that. Oftentimes, however, what we would like to do is take and pull out the right-hand side of this. And what I mean by that is it says y of t equals this. I just want this piece. You could copy and paste, hitting Control-C and then Control-V. I could also right-click on this, and where it says right-hand side, I could pull out just the right-hand side. That is very, very useful in this course. And there are many other things I could do contextually from looking at the menu if I right-click on the output. All right, I think that's a pretty basic introduction to differentiation. Now I want to take a look at integration with you. So I'm going to insert a section for integration. And on integration, there are several basic commands that you need to be aware of. Starting first and foremost with the int command. So suppose I wanted to integrate the function x squared with respect to x. Well, we should all know that's 1/3 x cubed. And then that's an indefinite integral. Suppose I wanted to create a definite integral. So I want to evaluate x squared between 0 and 1. Well, pretty easy. Let me get a little bit harder. If you recall, this function does not have an antiderivative. So when I ask Maple to take its antiderivative, it will give me an answer which is actually technically correct. It's just in terms of another function that we may or may not know anything about. So what I would recommend that we do in that case is, if we really need to know something, we will probably talk about the definite integral instead. And this curve exists and has area under it, so it makes sense that it would have a definite integral. And so there's its definite integral. Once again, not all that helpful because all Maple did was plug in 1 to that expression above. However, if we are tricky about this, we can take the previous command that I've just done and tell Maple that we don't want you to use your normal integration routine, which is used for finding antiderivatives. Instead, we would like for you to numerically calculate the integral. So it's going to use a numeric scheme rather than what we call a CAS or computer algebra system scheme. These are much more efficient and faster, and so if all you're looking for is a numeric answer, I highly recommend you using numeric integration this semester for many of the problems. It will be much, much faster. Similarly, if I want to do, say, double integration, then I can just integrate by nesting the integrals and doing one with respect to x and another with respect to y. And this would give me the double integral of e to the x times e to the y. I could also pull out double, triple integrals, indefinite and definite, from the context menu here on the left. All right, to see that, so let's pull out a definite integral. So I'm going to integrate from 0, tab, 1, tab. Let's just do the square root function again. So I'm going to integrate from 0 to 1 square root of x, 2/3. That's nice. I could also do indefinite integrals. Once again, nothing strange going on there. Suppose I wanted to evaluate this at a point. So I'm going to right-click and evaluate at the point x equal to, let's just do 0. So the evaluation there at the point gives -1. And to be honest, there's really not much more to say about integration. We're going to run into some specific things throughout the semester, but this is enough to get you started for now. And finally, I'm going to do a little bit with plotting. So when it comes to plotting in Maple, the things that you should be aware of are the basics for now, and then how to dress it up a little bit. So suppose I wanted to plot x squared on the interval from 0 to 10. If I do that, notice Maple is smart enough to pick the y associated with the x that I gave it. However, I could also tell it and specify a different y if I wanted to. I normally let Maple pick it for me unless I need it to be more specific. So once I have the window set, I can change the color of the line. So I now have a blue line. I can change the thickness of the line. The default thickness is 1. I can give the plot a title. So to do titles or to do any character strings, you typically want to use the apostrophe. So apostrophe, and I'll just call this plot of the function f of x equal x squared. Close that with an apostrophe. When I do that, I now have a title. Okay, in addition to titles, you can put in legends. So I'm going to create a legend for this curve, and I'm going to call this curve puppy power. So now it is labeled the curve on the graph puppy power. Okay, something else I could do is I could label the axes. So if I wanted to label the axes, I'm going to label the x-axis puppies. And I'm going to label the y-axis will come next, I'm going to label that happiness. And notice that in both cases, we're still using apostrophes because we're using character strings. So puppies and happiness. Okay. All of this can also be done by simply right-clicking on the plot and selecting things like legend, title, axes, playing with all the different options, contextual options that you have when you right-click on a plot. If we want to do more impressive plots, then we need to load a package called the plots package. Loading packages in Maple is a very important thing that we will talk about repeatedly throughout the semester. One of the main packages is the plots package, and the way you do that is by saying with plots. So with means it's loading the plots package. And if you simply hit enter here, it'll show you all the different commands that it loaded for us to be able to use. My suggestion is when you load packages to use a colon at the end of the line to suppress all that information. So now that we have the plots package loaded, I would like to plot x squared plus y squared equal 4 on the interval from, let's say, -3 to 3, -3 to 3. The reason I'm picking this particular curve is you should recognize that as a circle of radius 2, and I'm plotting it on a window big enough that we can see the entire circle. If I hit enter, you're going to notice an error. And the error that it's giving me is because plot, the command plot, expects to be plotting a function of one variable. Here, I'm giving it a non-function. I'm giving it a circle. Circles are implicit plots. They are functions of both x and y simultaneously equal to some constant. We've talked about implicit solutions in class, and if your solution is implicit and you need to plot it, then you have to use a command called implicit plot. So the implicit plot command works just like the plot command with one small exception. Once I hit enter, you'll see the circle. But notice I tried to tell it to plot -3 to 3 and it sort of ignored it. Well, when you have the implicit plot command, it will just draw out the curve and then shrink the window to fit the curve. If what I want is to view it on -3 to 3, I have to use a command called view. So the way that view works is the first thing is the x interval, and the second thing is the y interval. So I'm viewing this curve on an x interval from -3 to 3 and a y interval from -3 to 3. And notice that changed it so that I'm actually getting the window that I want. That's the only big difference between plot and implicit plot, is kind of how it affects windows. Otherwise, all the same color commands, thickness commands, title commands work. I could probably go on at this point and talk about a lot more plot things, but this is just a basics video and it's already starting to get kind of long. So I just want to leave with the most important thing I can tell you in this video, and that is if you get stuck on anything in Maple, Maple has a wonderful help system. If you go to help here at the top and select Maple help, it will open up a sheet like this and you just search for whatever it is you want. So maybe I want to know more about the implicit plot command. So I type in implicit plot, click on implicit plot, and then it gives me all sorts of information about the command, including examples. So this is where I go to all the time to figure out how to correctly do many of these commands, including some special options that a lot of these commands have. Things like refining grids to make things less jagged and appear more smooth. That's going to be a big thing this semester. So I'm not going to be able to tell you every little command you need to make your stuff look good. I will tell you that it's somewhere in Maple Help and that you should get used to looking into Maple Help to try to make your work look better throughout the semester, or have it accomplish exactly what you want it to. All right, this is the first in what I hope are many videos introducing Maple and its role here in differential equations. And the next video that you see will be going over dsolve and deplot, two commands which are very important to the course, and we'll probably have several more like that here in the next couple of weeks. All right, thank you for watching.